Computers today are extremely fast, and they will undoubtedly get exponentially faster in the future. Despite this, computing time is still a finite resource, and it saves time and money to design programs that run as quickly and efficiently as possible. In general, computing time is displayed in Big O notation, which is a quick and dirty representation of the rate at which the number of calculations scales with a dataset size. For instance, a program with O of n runtime would take twice as long to process a dataset with twice as many values, while a program with O of n squared would take 2 squared or 4 times as long to process the same doubled dataset. The steepest scaling is exponential, such as O of 2 to the n. This means that calculations would take twice as long for a dataset with just one more value, making the program only feasible to run for extremely small amounts of data. To time a function in MATLAB, use the tick and talk functions. The tick function starts a built-in stopwatch function that measures computing time to the millisecond, while the talk stops the function and returns the amount of time elapsed. The general syntax for these functions is to put tick on the line before whatever part of the function you want to time, and then store the output of talk in a permanent variable by typing the variable name equals talk. The stopwatch can be used multiple times and assigned to multiple variables, so it's easy to time each critical part of a function and record the execution time of each one. As an example, we can use the practice script that you created in a previous video. So I'll open that. And if we wanted to time this function, on the first line, we'd put a tick function, and then on the last line, we would put a talk function. Then when we run, we can see that it will now display that the elapsed time is 0.024 seconds. Optimizing functions themselves to reduce their big O value is an extremely complicated subject and beyond the scope of this course, but there are several coding practices in MATLAB that can significantly reduce the time a program takes to run. First, be sure to put semicolons after every line that doesn't have output that is absolutely necessary for the user to see. Writing output to the command window slows down the execution of the program substantially, and simple calculations can take an inordinate amount of time. This is especially important in loops or when dealing with matrices with hundreds of thousands of values. The second good practice is to allocate a variable only once. It takes far less time for MATLAB to define a 100 by 100 matrix of zeros and then fill it cell by cell than it takes for MATLAB to define a 1 by 1 matrix, then extend it to 1 by 2, then 1 by 3, and so on all the way up to 100 by 100. The zeros and ones functions are useful here since they allow you to set the dimensions of a matrix and fill it with placeholder data. Going back to the practice script, if we wanted to store all of the stock data in a single matrix, we would start by defining the matrix on the line above, stock data equals zeros of 10, 1, and then within the loop, we would say stock data of I plus 1, 1 equals each of the means. This would ensure that the matrix is defined only once, which makes it much faster for MATLAB to run. Finally, be sure not to make MATLAB do any more calculations or hold any more data than necessary to get the answer. It's easy to just make every variable a double or an unsigned integer with 64 bits, but this wastes a lot of space, and it forces MATLAB to do calculations on far more digits than is necessary in most cases. Symbolic arithmetic is even worse for speed. While it will completely eliminate rounding errors, it also takes many times longer to run than normal arithmetic. Variables can be left as high-precision values while you're writing the script to avoid any rounding errors while debugging, but once a program is complete, it can significantly reduce the runtime to go back and change variables to singles or 8-bit integers wherever higher degrees of precision are unnecessary.